All right, so as you guys know by now, this week we're just reviewing concepts from throughout the year, a lot of them coming from the beginning of the year in preparation for our project next week. So the videos have been short, the concepts have been simple, but it's important that you remember these because you're going to be using all of them next week as you work through your project. So let's just review. A linear function is a function whose graph is a straight line, has one independent variable and one dependent variable. So the form we use most and the form we're going to focus on today is slope-intercept form, y equals mx plus b. In this form, the dependent variable is isolated and shown as a function of the independent variable multiplied by some number with some other number added or subtracted. And this can model a lot of real life scenarios, one of which, or several of which, you'll see in next week's project. So let's just review how we graph these. Remember that we always have the slope times x plus the y-intercept, right? M is the slope, b is the y-intercept. Right, so that's our shortcut way of graphing, but remember all it means is to get a particular y value corresponding to x, you take the x value, you multiply it by 3, and you subtract 2. So for example, I know if x is 10, 10 times 3 is 30, minus 2 is 28. So when x is 10, y is 28. So the point 10, comma 28 should be on my graph. But our shortcut way of doing this is just using slope and y-intercept. And we should be able to recognize here that the y-intercept is, or b, is -2. And the slope is m, which is 3/1. So that tells us I want to start my graph at -2. And I want to go from there up 3 and over 1. Up 3 and over 1. And I can do that as many times as I want, or I can just put 2 points, that's fine. And then we connect those points with a line. So that's really all there is to graphing in slope-intercept form. We'll do a couple more examples, and we're going to look later at scaling these things because that's going to come in handy next week. So in this example, we know that the y-intercept, where we're going to begin, is b equals 5. And we know the slope, how we're going to move from there, is m equals -3/2, meaning we're going to go down 3 and right 2, or up 3 and left 2. Both of those are perfectly fine. So we're going to start with the y-intercept, 1, 2, 3, 4, 5. That's where we start on the y-axis. And we're going to move down 1, 2, 3 over 2. Or we're going to move up 1, 2, 3, that's +3, and -2 means left 2. And either way we do this, we get the same line, of course. So let's draw that line in. And it should look something like that. So on to the next page. The thing we're going to have to deal with next week is when these numbers are a little bit larger. Right, so we can see by looking at this, we can still find the same information. The y-intercept b is 15, and the slope m is 30, or 30/1. And the problem with that here is that if we count by 1, of course, this is way off the graph, right? 15 is up here, and then going up 30/1 brings us way even off the page. So what that means we're going to have to do is scale our axes accordingly. So if we want to be able to fit 15 and then go up 30 from there, right, we need to figure out how can I get at least like 45 or maybe even higher than that, 75 or 105 on this graph. And one good way to do that would be to count on our axes by 10 on the y-axis and just 1 on the x-axis. That way I can put on my graph 15 right between 10 and 20, and I can go up 10, 20, 30 over 1. Right, this puts me at when x is 1, y is 10, 20, 30, 45. When x is 1, y is 45. That's because we started at 15 and went up 30 over 1. So let's just draw that line in. And let's do the same thing here. So a couple points to be made here. One is that since there is not anything being added or subtracted, the y-intercept, b, is 0. But the slope m being multiplied by x is 55. So we have no problem putting the y-intercept at 0. That's right there at the origin, no matter what. But again, we want to think about how we're going to scale this, because I would need to be able to go up 55 and over 1. So counting by 10 seems like a pretty good option again. We might even want to count by 20 so that we can fit a few points on the page. And just to show that we can do either of those, really doesn't matter. 10 is fine, 20 is fine. Anything that's big enough is fine. 15 would work, 30 would work, whatever you choose to use is fine. But let's count on the y-axis by 20, and let's count on the x-axis by 1, because every time we go up 55 units, we're still only going over 1 unit. So we need to kind of cram our graph in that way by counting by 20s this way, but only 1s this way. So let's go up 55, 20, 40. This would be 60, so we're somewhere in here, and over 1. Up 55 over 1. Let's go up 55 over 1 again. So 20, 40, and a little bit less than 60. So 55 should put me about here. And we need to go over 1 also. So we're at 1, 55 and 2, 110. 20, 40, 60, 80, 110. So make sure you're comfortable scaling axes in that way, so that we can fit some relevant points on the graph for each line. And that's just going to be based off of how large or how small the y-intercept and the slope are. So that's our review of slope-intercept form. You have some practice to work on today. If you need help, of course, you can go back and watch this video or reach out to your teachers.